emitting diodes, LEDs, are the most widely used semiconductor diodes among all the different types of semiconductor diodes available today. Light emitting diodes emit either visible light or invisible infrared light when forward biased. The LEDs, which emit invisible infrared light, are used for remote controls. A light emitting diode is an optical semiconductor device that emits light when voltage is applied. In other words, LED is an optical semiconductor device that converts electrical energy into light energy. When light emitting diode is forward biased, free electrons in the conduction band recombines with the holes in the valence band and releases energy in the form of light. The symbol of LED is similar to the normal PN junction diode, except that it contains arrows pointing away from the diode indicating that light is being emitted by the diode. LEDs are available in different colors. The most common colors of LEDs are orange, yellow, green, and red. Let's see how light emitting diodes works. LEDs work only in forward bias condition. When LED is forward biased, the free electron from the N side and the holes from the P side are pushed towards the junction. When free electrons reach the junction or depletion region, some of the free electrons recombine with the holes in the positive ions. We know that positive ions have less number of electrons than protons. Therefore, they are ready to accept electrons. Thus, free electrons recombine with holes in the depletion region. In the similar way, holes from P side recombine with electrons in the depletion region. Because of the recombination of free electrons and holes in the depletion region, the width of depletion region decreases. As a result, more charge carriers will cross the PN junction. Some of the charge carriers from the P side and the N side will cross the PN junction before they recombine in the depletion region. For example, some free electrons from the N-type semiconductor cross the PN junction and recombines with the holes in the P-type semiconductor. In the similar way, holes from the P-type semiconductor cross the PN junction and recombines with free electrons in the N-type semiconductor. Thus, recombination takes place in depletion region as well as in P-type and N-type semiconductor. The free electrons in the conduction band releases energy in the form of light before they recombine with holes in the valence band.
An LED is a basic semiconductor device. P-type semiconductor material containing positively charged carriers called holes is combined with N-type semiconductor material containing negatively charged carriers called electrons to create a diode. When a current supply is connected to the diode, the negative charged electrons are forced to move one direction, and the positive holes move in the opposite direction. When a free electron comes near a hole, it combines with the hole. The holes exist at a lower energy level than the free electron, so the electron must lose energy to combine with the hole. This energy is released in the form of a photon, or a unit of light. The amount of photon energy released determines the frequency or color of the light. The type of material and process of creating the N-type and P-type materials dictate the color of the photons, as well as the efficiency and other performance characteristics of the LED. After processing the material into an LED chip, the chip is installed in a package that allows electrical connection and directs as much light as possible in the desired direction.